The people at the lab and other places around the country that study the global warming situation say that it is a serious problem down the road. How far down the road, I don't expect to see myself because I'm an old codger. But I think my grandchildren are going to see a heck of a big problem. Power reactors don't contribute CO2 to the atmosphere. And so they should, by golly, be pursued, period. And not to do it is sort of insane, really.
We hear so many people commenting, especially on commercials on TV, we have enough natural gas to keep us going for 100 years. 100 years is a very short period of time.
It's hard after you've been exposed to the potential of thorium to be satisfied with 100 years anymore, isn't it?
Even if you say that we can still go up into the polar regions and drill under very difficult conditions without disastrous after effects or side effects and bring that out, we still have a finite source of fossil fuel materials.
Well, Jess rolled out the red carpet for us.
They got to see everything. Yeah. As much as we could cram in one day, we did.
I think we got a really good sense of what capabilities Oak Ridge has to support molten salt development.
30 years have passed. An example is Hastelloy N. Our materials guys said, why do you want to use that? That's a 1950s alloy. We can do better than that today.
Well, I'll wait until Dick comes back, but I'm very happy to explain how I came to be interested in all of this. Nuclear power is a big topic of discussion in the UK at the moment, and I want it to be a very informed discussion. I don't want us to just take the word of one company or one set of industrialists, which is sometimes what happens, and I want us to have a really good, thorough understanding of what the alternatives are.
Well, is your government going to be able to help you with this?
I'm in the opposition party, so I'm the equivalent of a Democrat, but we're out of power at the moment, looking at how our party can create a kind of policy that has, there's a coherent policy.
These issues should really not be that political.
I agree completely. The challenge of being in opposition is that we have no resources, but the benefit of being in opposition is that you don't get lobbied so much. I came to this through Kirk, really, hearing Kirk talk at a conference in Manchester about 3 or 4 years ago, where he was presenting the MSR to a new audience, and we were blown away, really.
I've seen some of his talks on the web. They're very good.
Well, I've been in this energy game for about 10 years now, and no one's ever told me there was a safer, more sustainable form of nuclear. So I was kind of instantly interested, and I kept thinking about it occasionally. I kept in touch with Kirk a little bit, and then Fukushima happened.
This is great. This is just what I wanted to have happen, is her talking to these guys and getting that straight up. Oh man, it's just perfect.
Good.
It's just perfect.
I don't know, Dick Engel's probably the most knowledgeable person around these days, right?
Dick's real chatty, and I've never met Sid. I have all his, not only have I read all his papers, I've actually extracted all the text from him, converted it all, rebuilt. I don't know if there's anybody that studied his stuff more than me,
I've worked with him almost the whole time I've been here.
I was so tickled when I found out he was alive for the first thing.
He just retired.
He showed how the steam generator was a real problem in the dynamics because it was not smoothly modelable in their equations. It was more of a discontinuity. And I looked at that dynamic model and I thought, if we coupled this reactor with a Brayton, I'll bet the dynamic equations would be a whole lot smoother and more amenable to, because everything, you don't have that boiling, you don't have that kind of almost discontinuous derivative like you do with, with steam.
I started out at the lab in 1957, and shortly after I got started at the lab, I got onto the molten salt reactor project, the MSRE, Molten Salt Reactor Experiment Project, mainly in the instrumentation and controls aspects of it. But I quickly got into the dynamic analysis, which was a lot of fun for that reactor because it's an inherently safe reactor. The dynamics were, let's say, not common to reactors because it was molten salt instead of water-cooled solid fuel reactors.
We had input into the program, the experimental program, as well as the analysis of the results of that program.
A lot of people don't know very much about how nuclear reactors work and the notion of dynamics and so forth. They don't understand it. Often folks are afraid that a reactor can run away on them, that a reactor is somehow an inherently unstable system that people have to always be keeping their eye on lest it get away.
Nuclear processes are pretty well understood. There are certain designs you can make of power reactors that will, let's say, be self-controlling. In other words, if the power tends to go up and the temperatures go up, it automatically corrects and shuts itself down, or at least doesn't let it keep going up.
And is it very hard to design a molten salt reactor to be self-controlling?
The nature of the molten salt reactor, the one with the fuel mixed in with the salt, is basically inherently safe and, you know, self-controlling.
Depending on the particular configuration, just about any molten salt concept that has been seriously considered has been shown to be to have this stable behavior.
If you have the molten salt in the core region and it heats up, it gets less dense, and that means it's less likely to go more critical. In other words, it gets less critical as the density.
Or less reactive.
Yeah, less reactive.
Yeah.
And this isn't theoretical for you. You actually operated the molten salt reactor experiment and verified these behaviors, correct?
Yeah, well, I wasn't an operator, but I did run experiments on it and showed what everybody else had already showed, and we had all proved that it has characteristics that make it inherently safe.
How did you feel about the reactor now? I mean, it sounds like it was quite a boring job in a way, but did you feel fondly towards this reactor design?
Oh, yes.
It wasn't at all boring.
I meant boring in the sense that, you know, it was kind of safe and
Did exactly what we calculated it ought to do, and that's pretty satisfying.
Yeah. Can you remember who solved the valve problem? Who came up with the frozen plug idea?
I was the one that developed essentially a flattened 1.5 inch pipe with electrical heat, resistance heat on that one.
So you invented the frozen plug then?
Sorta, yeah.
Well, it's a really important safety feature then, isn't it?
Extensive use was made of frozen salt. Everything in this cell, the primary piping, was put together with flanges about this diameter, and the gap between the flanges was fairly narrow. And while there was a buffered seal at the outside, the principal seal was salt that was allowed to escape partway out into this narrow space and freeze. The salt never came in contact with the gas-tight seal. We used it on the aqueous homogeneous reactors at ORNL as well when we did maintenance there. We just wrapped coil around and used Freon as a coolant there to freeze water plugs in the pipes for a component that was to be removed.
Now, why do you want the frozen coolant in the pipe for maintenance?
To seal it.
To seal it, to isolate it from the rest of the system.
So you don't have to have a mechanical valve. You just freeze the water in place and then it plugs.
Oh, so I see. So you'd freeze the remaining portion and then take out the.
Yeah.
Yes, this salt is molten on either side of this until you're ready to drain the reactor. Well, the pump, of course, for the same reason, had to be very special. Had to keep the molten salt away from the seals and the bearings, so it's an overhung shaft sump pump, we call it, with a helium blanket when it had to be at the
The gas-liquid interface was in the pump tank itself. The tank was 3 feet in diameter.
Top of the system, of course.
So the cover flow, the cover gas, was to keep the salt away from the bearings and the...
Right.
Interesting.
It's often talked about that the reactor was so safe you could switch it off, go away for the weekend and then come back.
Operating the reactor was relatively boring. I mean, you sat there. One had to make control rod adjustments now and then to maintain the temperature, the operating temperature. As fuel was consumed, the temperature would tend to drop, so you withdraw the rods a bit. But you could change the load on this radiator by moving the doors down, changing the load, and the reactor would follow the load. So in that sense, and it didn't take any significant control rod action. Of course, there was an automated servo control system to keep things stable, but it did very little.
By stable, you mean at your desired level?
Yeah.
But it wasn't basically unstable. It would control itself. As a matter of fact, I was running some tests late at night. It was one of these things where you perturb it and watch the response to rod motion. And the device that I was using got stuck in the wrong place and pulled the rod out, and the power went up and up beyond the design power, and then controlled itself and went back down. Wow. Everybody was happy. And I didn't
Take the reactor prompt critical? Was that what happened?
No, it wasn't prompt critical. It was just more critical enough so that the power increased.
Do you remember what power it went to?
Maximum power was 8 megawatts. It went up above 9 megawatts anyway.
Well, enough to heat the salt to a new stable temperature. With the additional reactivity, the stable temperature was somewhat higher. So once it heated the salt to its new stable temperature, it flattened out.
Well, it went up and then came back down. But I didn't even have to write an incidents report for that.
It really is true, Sid. I've reviewed all of the documents on dynamics and control, and Sid's name is all over them. Before I left Teledyne, I was almost exactly trying to replicate your model for the MSRE.
Oh, yeah.
And really great honor to finally meet you tonight, because I feel like I've been following your work.
But as far as this, this story of just closing off the heat exchangers, that never happened, right?
You didn't
switch it off for the weekend.
No.
And you mentioned it before, but it could load follow, or it followed the load. So could you just talk me through that in basic terms?
Well, what happens is if you extract more heat here than the reactor is producing, you cool the returning salt to a lower temperature, which in turn cools the fuel salt. So the salt that enters comes in at a lower temperature. The lower temperature causes an increase in nuclear reactivity, the negative temperature coefficient of reactivity.
Yep.
And so the reactivity of the system increases, thereby allowing the power level to rise, which heats the outcoming salt to a higher temperature. And so the whole system operates over a wider temperature spread.
If he once got the reactor critical at constant temperature, didn't have to change the control rod at all. All you had to do is increase the coolant, and it would come to power all by itself.
Yeah. There was some concern along the way about the stability of the dynamic stability, because at the lower powers, the power would, if you didn't use control rod motion to correct it, the power would oscillate. And the more power, the higher the power, the less the oscillation.
When you said oscillation, over what period?
Quite long, maybe half an hour or so, half-an-hour period. And then as you go up in power, it became more stable, but what oscillations there were at a shorter period.
Some people point to the cost of the cleanup and they go, molten salt reactors are a bad idea because look how much this reactor costs to clean up. But it didn't represent some fundamental design flaw in the concept, which is how some people present it.
Yeah, that's true.
Well, we heard quite a lot today when we visited about the cleanup operation they had to do because the salts had migrated all the way to the charcoal beds, and apparently that they were told when you guys left, you know, you should probably clean this out within 30 years.
Dick was the one that told them.
We told them that for $50,000 we can take all of that U-233 out of there and it won't be a problem. They have spent
Much more than the cost of the MSRE.
1970. They have spent probably more than $50 million
Yeah, that wouldn't surprise me.
on the cleanup by now. We knew that as the salt sat there cold, it would be subject to radiolytic decomposition that would release fluorine. And we had run samples in small capsules in reactors, and when you heated these capsules up, the fluorine went back into its normal state with the UF4. What happened on the reactor was that it wasn't in a confined capsule. And as this fluorine was formed, it latched on to a uranium atom here and there and made UF6. UF6 is quite volatile and it diffused throughout the system. As they periodically heated the salt nominally to recombine the fluorine with the other ingredients, it really just pushed the stuff farther out into the charcoal beds.
A good lesson learned, maybe, or perhaps not.
Well, they should have taken care of it, you know, a couple decades ago.
Penny wise and pound
It was
foolish.
just a lack of funding at the right time.
Yeah, well, my impression was that the people who made the funding decisions in Washington decided that they had better uses for that money than cleaning up this system, which we believed was quite stable. And so they just failed to provide the funding that was needed.
The other thing that everyone talks about is corrosion.
One phenomenon that we observed that could be called, I suppose, corrosion was the intergranular attack of the hastelloy by tellurium fission products, because the oxidation state of the salt was such that tellurium was present in its elemental form as opposed to either a positive ion or a negative ion, which would have stayed in solution. Elemental metallic tellurium deposited on the surface of the hastelloy and crawled on in among the grains. They have done, since that, they did experiments and said, well, if we manipulate the oxidation state just a little bit, we can prevent this. Well, I am not convinced that that is necessarily the final solution, because if you look at the salt that's in the reactor, it has the whole spectrum of rare earth elements in the salt, tellurium being just one of them. And if you take care of tellurium, have you moved conditions such that some other element takes on the tellurium role and does the same thing? And I don't think there has been enough work done to demonstrate conclusively that that problem is fully solved. Now, I have not been current with everything that has been done.
I don't think there's been any additional work since that time on it.
And the tests they ran were a few hundred hours. Now, to really qualify a material, you want tens of thousands of hours of exposure. And that hasn't happened. That will have to happen before you can say you have a viable, commercially interesting product.
Would there be a way that that experiment could be run like in the HIFER, like putting some small salt samples in a capsule and exposing them to different materials? simulating a much longer.
That's one way to do it. The other way to do it would be to simply conjure up a witch's brew of salt with a fission product mix that is comparable to what you expect in the reactor.
Nothing radioactive, just
Would not have to be radioactive, just use the stable elements.
yeah.
And
Basically, put everything in there that's
one can calculate what the mixture will develop as the fission process goes on. And all of those elements have stable nuclide, stable isotopes.
A lot of the tellurium work was done with stable tellurium.
Yeah.
I mean, they observed this after MSRE was shut down, but all the research to investigate it and look for solutions was done with stable tellurium.
So that could be got going without it needing to have a criticality or any kind of, it's just a material science
It's a
problem.
high temperature,
High temperature material science problem.
relatively high temperature.
The MSRE was highly successful as a first of its kind, but there were an awful lot of things that you need for a functioning power generating station that were not addressed on the MSRE.
Yeah.
And developing all of that is not going to be a trivial exercise. It's going to require time and funds and determination.
Well, and the other thing, I worked a good bit with the licensing problems on the HTGR. And we had this, the modular HTGR has this inherent safety. You know, the design is such that if everything craps out, no auxiliary power, you don't even scram, it heats up and shuts itself down and everything's cool, no damage. And you'd think that when we work with the NRC, the Nuclear Regulatory Commission, on getting this license, it would be really quite easy. Well, it ain't. They're just not used to it. And they cycle people into the program. Historically, they cycle new people in, and then they'd cycle them out, and then a new group would come in. You'd have to start from scratch to get them going. The licensing for the gas reactor program has been a real pain, and I think when the molten salt gets to the point where people, have a good design and want to push it forward and commercialize it, they're going to have the same kind of problem.
I think in spades.
Yeah.
So it sounds like you each worked on a number of different reactors over your careers.
Everything I ever worked on got canceled.
Not because of him, though. What's happened to Paul Habenovich and Beecher Briggs and those guys? Have you kept track of them, do you know?
Well, Beecher's been dead for a long time.
How about Paul?
Well, I have not had any contact with him, so I don't know.
One thing that's important to remember is there are a number of the people that worked on the molten salt reactor work that would come back and then they get shut back down. They come back and they get shut down. A lot of people got burned out from that pattern.
What's more likely is that quite a few of them are dead now.
Well, that's true too.
MSRE was canceled because, have you seen this? I won't read it to you.
Why did U.S. discontinue research and development on molten salt reactors? Weinberg to Seaborg. Our problem is not that our idea is a poor one, rather it is different from the main line and has too chemical a flavor to be fully appreciated by non-chemists. And then McPherson said in 1985, political and technical support is too thin geographically. Oak Ridge is the only stakeholder. The liquid metal fast breeder reactor program got early start, had major federal funding and many stakeholders. And reduction in uranium demand and need for breeders. Interesting. We visited with Mr. Rosenthal after we met with you, Dick, and he said that he spent time in Washington, D.C. with Milt Shaw, and that Milt actually had quite an affinity for Knoxville and Oak Ridge, but that he wanted Alvin Weinberg and Oak Ridge to get on the fast breeder funding wagon to help build the Oak Ridge base, and that Weinberg wanted to stay on with thorium and molten salt, and that was the wedge that ultimately drove Milt and Weinberg apart, was the whether Oak Ridge should follow the fast breeder efforts that other labs were doing or stay with molten salt and other programs.
Well, it was pretty obvious at the time that Shaw was completely convinced the LMFBR with its sodium cooled system was going to be successful, had much better performance characteristics from a neutronic standpoint than the thorium-based system. And one had the feeling, if we have a winner here, why spend money on what we know is going to be the loser?
So everyone was so just euphoric about the idea of the fast breeder.
Well, that's the way it appeared to me.
The Baroness has got a bunch of people over there from GE saying that you got to go build a fast breeder.
I'm not sure I'd want one in my backyard, but the Russians are building them, and we built a couple of them. We had a couple problems with them actually, but in principle, I guess you can go that route. But relative to a molten salt reactor, you've got a lot of fuel cycle infrastructure that you wouldn't need if you went to the molten salt reactor. So I wouldn't do it. I wouldn't build fast breeder reactors if I were the person deciding. In terms of consuming or getting rid of the problematic acrylides that come from light water reactors could be better done in a molten salt reactor.
In the U.S. nuclear Navy program, they started out with 2 reactor systems, one water-cooled and one sodium-cooled. And it didn't take very long for the Navy to decide that they didn't want to deal with sodium cooling.
They built a reactor and put it in a sub, and they ended up cutting the reactor out of the sub and putting a LWR in it.
Because they were so worried about the sodium interacting with air and water.
Well, I think it was just, I don't know if that was necessarily the only issue, but there were a number of issues I think that were of concern.
But they became disenchanted with sodium cooling rather quickly.
We were competing with the fast breeder people at Argonne mainly, and like those quotes indicate, they just had more political sway than the molten salt reactor. I think there were maybe 2 or 3 guys from the molten salt project that would go to Washington and do the dealings up there, and the rest of us would be back home working. Now, when we have a reactor project, just about everybody on the project spends time dealing with the bureaucracies, and therefore less time and money available for the real work on the project. And that's a sad state of affairs,
I agree.
think.
Do you feel like the program had a sound technical basis, or do you feel like technical problems were the basis for cancellation?
Some of the technical reasoning that I heard for the cancellation was that there was a corrosion problem.
Or let's say the materials problem with the structural material was one. Tritium was raised as another issue. We made no effort on MSRE to do anything with tritium, and there was a perception that managing tritium was going to be a very difficult, if not insurmountable, issue.
People who were the decision makers in Washington?
I didn't know who the decision makers were, let alone what their reasons were. The things that I'm mentioning here are things that were published subsequently.
This is the WASH 1222 report from the AEC. Did the people on the program feel like tritium was an insurmountable problem?
We recognized that tritium would have to be captured and sequestered for the system to be viable, but most people thought that that's something that we should be able to do.
Did the people on the program particularly the chemists or the material scientists, feel that corrosion was an insurmountable problem on the program?
No. I think the people that I dealt with or that I spoke with felt that, okay, this is an issue, specifically the tellurium issue, but we can get around that. And in some of the subsequent work, subsequent to that initial shutdown, they did some experimental work that seemed to bode very favorably for an ability to solve that issue. As well as the tritium issue, by the way, because we did do some tritium experiments in that 1974 to 76 period, and those are documented.
Were either of you present when the molten salt reactor program was canceled in the early 70s?
Yeah, we were still working there.
Well, I was still working on the system. We were still finalizing reports on the performance of the MSRE.
Sid, how did you feel when it was announced that the program was canceled? Did it come as a surprise, or was it something that you saw coming?
I didn't see it coming. And yes, it was a surprise, but I was not privy to the politics at the time.
The original shutdown came early in 1972 with a letter from Mr. Shaw that says, "Thou shalt stop right now." And one anecdote that I heard, and I don't know personally, said, "What do you mean?" He said, "Well, you put your hand on your desk on one side, take everything that has to do with molten salt, sweep it off, and you're finished." It didn't really happen that way, of course.
I saved all my documents.
I did too. We did spend some time finishing things up. But then, 2 years later, there was action in the Congress to revive the molten salt program, largely at the instigation of Senator Howard Baker, who was the local senator. He extracted from the Congress a promise to restart this program and continue it until successful completion. Lasted 2 years, which is typical of congressional actions in this country. The Congress changes and everything changes.
Do you think building molten salt reactors in the future would be a good idea?
Oh, heavens, yes.
Dick, what do you think?
I think it would be a very good idea.
Thorium resources are known to be very plentiful, especially in India and Brazil. And I think it certainly makes a lot of sense that India is going that way, looking at use of thorium as a fertile material. And I think we should also be looking at that, especially since it can be used by reactors such as the molten salt reactor and the high temperature gas cooled reactor.
Yeah, I think it would be tragic if we don't follow this and end up buying another technology from foreign powers in other parts of the world without identifying any particular foreign power.
Yeah. Well, just in case it's China. China currently makes my squash rackets, and pretty soon they're going to be making my reactors if we don't turn this around a little bit.
Well, unlike most people, gentlemen, you two did something about it a long time ago, and thank you very much. I greatly appreciate all your work. Thank you, and thank you for your time too.
And thanks for dinner.
Exact same thoughts for me. Thanks for all your work.
Thank you.
You're very welcome.